Hello and welcome to the next edition of the BobCAD-CAM webinar series. Today's topic is 3 ways to edge break. Day 1, I don't know if we'll get to a day 2. We'll see if we get through it or not. Let's see the overview. The goal of today's webinar is to gain confidence in 3D programming by learning 3 ways to program a radius edge. As you know, my name is Al DiPaolo. I'm the voice of the BobCAD-CAM BobCAD After Dark video series, the BobCAD webinar series, in all of the BobCAD Facebook groups. You can find me on Instagram at BobCAD-CAM. Let's see, what are we going to learn today? We're going to talk about geometry selection. When it comes to 3D machining, even if it seems like a simple edge break, there are a few things that you want to pay attention to. So we have geometry selection. We're going to talk about toolpath settings. We're going to review 3 toolpaths with you here today. We have the Mill Standard ZLevel Finish. We have the Mill Professional Advanced ZLevel Finish. And then we're also going to show the Mill Premium Cuts Along a Curve. And as always with BobCAD, you can expect what? Fewer steps, better cuts, and more profit. All right, give me just a moment while I get my screen set up here. And while I do that, why don't you go ahead and give me a quick shout out. Let me know who you are and where you're from. I love hearing from all of the different users that come up from all over the world. So let's go ahead and see where you guys are from. I know I got Reginald from San Diego. We got Scott from Massachusetts. Let's see, we got Rod from Idaho, Vic from Ohio. Thank each and every one of you for joining us here today. Vic from Ohio, Dave in Arizona, John in Palm Harbor, John in Claremont, California. We got Cincinnati here, some Skyline Chili Dogs. We got John from Ontario, Ken from Houston, David in St. Pete, Scott in Kalamazoo. Very good. Larry in Oregon, Rick in Tampa. We got New Mexico. Let's see here. We got North Carolina, Switzerland, Spokane, Washington. We got Southampton, England. Barry, thank you again, each and every one of you, for spending some time with me here today. I'm super excited about today's webinar. You know, we're talking about time-saving features you guys can use. And the one thing that I hear over and over from our customers is the speed and quickness that you can get into your toolpath and code with BobCAD. So I wanted to talk about a couple of those things today. Again, here's the 3 toolpaths that we're going to review. We have the Mill Standard ZLevel Finish. This is a Mill Standard ZLevel Finish. You have to have a Mill Standard license to have access to this. So basically, you Express users won't have access to this toolpath. We have our Mill Professional Advanced ZLevel Finish, and we'll talk about some of the differences between the standard and the professional and why you may or may not want to use those features. And then the last toolpath that we're going to review here today is going to be the multi-axis, or the Mill Premium Cuts Along a Curve. Okay, so those are our 3 toolpaths, our 3 ways to break any radius edge or broken edge, and we're going to just jump into it. Now, the first question that I have for each and every one of you, that means you, Walter, that means you, Wayne, that means you, Tom, okay? Everybody that's in here, I want to know, what are some of the challenges you face when 3D programming? If you had to machine this part here, and I know it looks simple, sometimes it looks super simple. You know, what are some of the challenges you face? Go ahead and throw some questions out there for me. Give me an idea of what you run into when you look at a part like this, or similar to this, or any 3D part, and you're not sure what to do. Edward comes in with extending surfaces. That's a great point. It's always a good rule of thumb to start and finish off surfaces. You guys got no other questions there? You guys are all massive. Okay, here, Scott, unnecessary retracts. Great point. Keeping the tool in the cut so that it doesn't go up and down. Tom's got edge selection versus face selection. Great point. How do you select your geometry? Mike's got a question here. Getting the path that is optimal for the cutter. That might be cut direction. That may be how it starts. Lead in and lead out. Grant has a question here from True North Cal. I'd like to know how you change the inner drop rectangle into a circle and tube, and how you can make individual size radiuses leading into the drop rectangle, in other words. I think you're more on a CAD step there. Let's see if we get some time later today, Grant, Larry had a question, getting it to cut only what I want, not too far, yet get it all with a ball nose. Another very popular question or scenario, how to get the tool cutting where you want and not where you don't, and getting it to cut it all. Walter has a question, the only selecting a portion of the geometry to cut, which these are all really good topics, okay? You know, what you select, how you select it, your toolpath settings, and that is what we want to review today. So thank you, each and every one of you, for those that did answer. I know there's a lot of you that didn't, like Paul. I don't think you said anything there, and Mike, I'm not sure. There's a lot of Mikes though. Linda, it's okay. You can fire questions away as well. We're all here to help each other, and today is going to be an awesome webinar. I hope you guys are pumped up. I know I am. Brian had a question, best step over based on the tool diameter. That's another really good question. Your cusp height calculation and what step overs you should be using, or what size tools you should be using. These are things that have to do with your equipment, your part, your experience, your software, all together. Okay? So thank you for a moment. Now, I got another thing for you as well. As you know, we do run special promotions just for webinar attendees. Today, we have a special promotion. If you're going from Mill Standard to Mill Pro, you're going to get a special promotion. If you're going from Mill Pro to Mill Premium, we got a special deal for you as well. All right. How you take advantage of this promotion is really simple. You call this number 877-333-4903, and I will post it into the group a little bit later. The promo code, you're going to call in and you're going to ask for the level up promotion. Okay, the level up promotion. You level up from Mill Standard to Mill Pro, or you level up from Mill Pro to Mill Premium. Okay, so that is the promotion that we're running this week. You can get it only if you've attended the webinar, and it's with the 877-333-4903 number with the promotional code level up. Okay, all right, very good. It's like paying the sponsors, right? Okay, so let's look at this. The first one that we have here is our ZLevel Finish. Okay, ZLevel Finish is our standard 3D toolpath. If you are new to 3D, or if you just haven't programmed a lot of 3D parts, you have a couple of primary toolpaths, ones that you use very often. You have a Z-level style, and you also have a planar style, okay? Z-level toolpaths are great for vertical walls, but they do really bad on shallow walls, okay? So as you can see towards this top section here, where the radius, the area of this surface is more flat, you can see we have a greater scallop here. And then as the radius, as we get steeper, you can see the toolpath gets closer and closer together, okay? So generally speaking, with the Z-level Finish, we're looking for more vertical walls, or steep geometry, and that's where that toolpath is going to do best. Now, there's a couple of things we're looking at here. This blue geometry, if we bring this back here, this blue geometry is the lead-in, okay? So you can see we're going to lead into our surface here. We're going to run a path around, and then this position move where it goes from here to here, this is called a link move, as it links from one slice to the next, okay? All right, so that's our Z-level Finish. Some of the problems we deal with Z-level Finish, or some of the scenarios that have to do with this toolpath, has to do with this top edge here, trying to get a consistent finish all the way throughout the part. Generally, the rule of thumb here is what you're going to do is you're going to drop your depth of cut value. Now, depending on the finish that you're looking for, you know, is going to determine the step over amount that you may be using. You also may want to use a larger tool. Using a larger tool will allow it to be more efficient using a larger ball mill, depending on this geometry. But again, even as we tighten it up here, these flat areas, you know, you're not going to see quite as many passes. If you tighten it up too much, you're going to get a good result, but it's not going to be as efficient. So we're going to talk about that. Hey, Wade, thanks for showing up here today. All right, so that's our Z-level Finish. The next one we're going to look at here is the Advanced Z-level Finish. Now, this is basically the same toolpath. You can see it starts at the top and then it goes down to the bottom. In this particular example, this is a spiral routine. So as a spiral routine, what it does is it stays in the cut the whole time. Okay. If we look at this toolpath either from a front view or from Maybe if we hide our model here or make it transparent, you can see there are no link moves. Let me go to just the top view here. You can see there are no link moves. It leads in and it's going to work its way all the way around, but there are no link moves. So using the advanced ZLevel Finish, you do have the option to use a spiral routine, and that is one of the advantages of it. If we go back to the mill standard, you can see this green and purple lines here. These are our link moves. This is definitely going to leave a mark in your part because you're going to have a change of direction. Generally, it's acceptable, or there may be other processing like coding or finishing that's going to happen. But because it's linking directly on the surface and changing direction, you'll be very aware that that is where that lead-in position would be. Or I'm sorry, that link position. When we go over to the Mill Pro here, where we're using the advanced ZLevel Finish, because we made it a spiral, we're not going to see those link moves, so it's going to stay in the cut more consistently. Reginald has a question: would equidistant work for both vertical and horizontal walls? Yes, equidistant is a catch-all toolpath. It does machine to the area of the surface, so it is a good solution in many scenarios to get areas that are both steep and shallow. So that's a great comment that you have there. All right, so we have ZLevel Finish. We're going to talk about some more options there as well. Let's go over to this other one here. This is the Mill Premium toolpath. This one's cuts along a curve. You know, the difference being with this one is instead of running, parallel to the surface here, we're going to see more of a perpendicular. I don't know if I'm saying that exactly right, but you can see it's going up and down versus running around the surface here. So this one's with cuts along a curve. There's a number of ways that we could attack this with the Mill Premium, but I just wanted to show some different options that we have there. Okay. Now, are there any questions about these toolpaths before we move on? If there is, go ahead and fire away. Otherwise, we're going to just get started. Starting from scratch, I'll set up the part and kind of move through this. Okay, I don't see any questions coming in, so what am I going to do? I'm just going to take my model here. I'm going to go ahead and do, let's see here. Grant said, can you add extra toolpath on ZLevel? You're going to have to describe that a little bit better for me, what you mean by extra toolpath, okay? So let's go ahead and copy this. We're going to cancel. We're going to get into a new file here, and we have our part geometry. Okay, so the first thing that I would say to you guys, whether you're new to BobCAD or in general, you try to let the tool do as much work as possible. If you can get away with a radius end mill, a corner rounder, we can come in here and profile this in one shot, you know? So keep that in mind. If I measure this radius, I have, let's see, a 1/2 inch radius here. So if I didn't want to use a ball mill and I wanted to break this edge, right? I could come into Mill to Axis, select my geometry, okay? I'm going to select this edge here. I'm going to just go over this edge. I'm going to right click. I'm going to choose Constant Z. That will select my geometry for me. I'm going to click OK to it. I'll go to my machining strategy. Okay, you don't see the corner rounding tool in the template list. You're going to see it over here. So what I'll do is X out my two operations, throw the corner rounder over there. You know, to get the right size, I'll go to my tool database here. Let's see, I'm looking for, what is it, a 1/2 inch radius. This is diameter corner radius. Let's see if I got one of those. The largest one I got here, we'll say OK. There we can see the tool. I'll compute it. You can see that we have our corner rounding tool that's going to come in here and cut around this. Now, I think I need to set my depth properly for this one, but you can see if you can use the tool for it. Let me see here. What do I got going on? Standard, probably run a lead in here. This is total depth of cut here. This is going to be 0.5. We'll recompute that. Now we can see our corner rounder getting in here and putting that radius on there. I probably want to add a lead in, so I'll edit this. I'll go to leads. I'm just going to do a right angle lead in here. Okay, so we can get a right angle lead in. It could be a blended one or whatever is going to work. We're going to come down, come into the shape, and we'll corner round our way and be on our way. Okay, so if you can do it with your tooling, that is a great way to go. Ron has a question on the mill premium. Can you make it cut in only one direction? Yes, you can. Okay, you can. So we'll get to that. The first thing we need to do is we need to go through our mill standard here. So we're going to right click on our machine setup, mill 3-axis, select geometry. Okay. Now, if you are a new user, okay, and you're not familiar with BobCAD, you may say, well, this is what I want to cut, so this is what I'm going to select. All right. So we select that. We come into our strategy. We do our ZLevel Finish here. We'll come in and set our tool size. We'll look at some of our settings here. We're just going down this list to answer the questions. I'm going to loosen my tolerance here, and I'm going to compute my tool path. Okay? And so if we go back to our feature here, if we click on our geometry, we can see just the geometry that we selected was just that radius. At first glance, it may look like it did a good job, but if we hit S on our keyboard, we're going to see the tool path is actually cutting on both sides of the surface. Okay, so it's looking at both sides, and it's not stopping on this top surface. It is possible to come in and maybe pick up this edge here as our boundary and recompute it. So we selected just the surfaces we wanted to target, and then we used a boundary to isolate it. That is a possible way to go about this, but generally as a rule of thumb for new users, when it comes to 3D, what I would do here for my geometry selection is I would select the whole model. Okay, so instead of just selecting the radius here, I would select the whole model. But in this example, it would work. Grant had a question: can you add extra toolpath? All right, I need more information, Grant. Talking about the direction there, we'll look at that some more. Brian, are you cleaning out the part or cutting all the material? Right now, I'm just working on just the edge. So we've already cut a pocket in the center there. We already roughed it out. We covered that in our 2D webinar. So if you want to pick up, you can watch that one and see where we're at. Reginald, can you do multi-step with a corner rounder? That is actually a great question. I deleted it out, so I can't go in and check, but there are ways to accomplish that by using a toolpath pattern if it's not in there. Ken had a question: is it necessary to show the initial stock? Okay, when it comes to ZLevel, showing the stock or not, when it comes to ZLevel Finish for mill standard is not a stock aware toolpath. If you're in the mill professional, you have stock aware toolpaths, so you could define the operation stock to help with trimming out unwanted moves, or you could or some of the other toolpaths are stock aware. This particular toolpath, ZLevel Finish, is not stock aware. Okay, so a couple of things. We have the geometry we selected. Okay, we picked just the radius. Usually not what I recommend, but it is a way that you can accomplish it. We used a boundary to contain the toolpath, so we want it to stay inside of this area. When we look at our toolpath, some of the common questions might be: can you change where the start position is, where it starts from? The answer is no, you cannot. Some of the questions might be: can you have it start from the bottom and go to the top? And with the mill standard ZLevel Finish, you would not have that option. If we look at some of the options that we do have, we could go to our leads and we could add a circular lead in, so that way we can ramp in and ramp out on the first cut. Some of the other settings that we may adjust is our DOC, or our depth of cut. Okay, so we could make this a smaller number. All right. We can recompute here, and then you'll see that will tighten up the step down, and it added a lead in and lead out. Okay, so what are some other settings here? Now, generally, so let me back up. Let me remove and let me remove. I'm going to select the entire model this time. Okay, I'm going to select the boundary again. I don't know that I needed to unselect it the first time, and I'm going to recompute. Some of the things that you may want to control is where it starts cutting and where it ends cutting. Okay, so right now you can see it starts at the top and it's going all the way down to the bottom of the geometry here. On the pocket that's in the center, most likely than not, we would have profile finished that wall because it'd be more efficient to do so. So we don't want the toolpath to run all the way down to the bottom. So we want to be able to edit where it starts cutting and where it ends cutting. The way that we do that is we edit our feature. Okay, we go to our parameter settings. You have your depth options for top and bottom of job. We can go to bottom of job and either pick or enter a value. Okay, the bottom of job is based off the machine setup location. So if we had it on the bottom of the part, we might be in a positive number. If we have the machine set up on the top of the part, it might be a negative number. If you're not sure, it's okay because you can just choose pick. So we could choose pick an edge, and then it will tell us where we need to be. If we want to extend to have it go past further, we could add a plus value here. Maybe we have it go down to 700, recompute, and that's where we're controlling where in Z that toolpath is going. So instead of it going all the way down to the bottom, we have it going down to our defined layers. Okay. If there's any questions about the standard ZLevel Finish, let's go ahead and ask that now. Otherwise, we're going to move on to the Mill Pro. Ron has a question. If you wanted the center of the ball mill to go to the edge of the radius, do you need to make an offset boundary? Really, what's happening here, the center of the tool for the boundary, it actually does go to the center of the tool, Ron. For mill standard, that's the only way that the boundary is used. We could offset our boundary. We could extend our boundary out further, but the issue is this surface is it's shallow. It's flat, And as the radius here, see what he's talking about is getting more passes, to go past this edge here. So if we offset our boundary here, is it going to get us more passes here? I'm not sure. I don't think it will, but let's find out. So we'll do this real quick. We're going to extract edges for this face. Okay, so we have some wireframe. The reason why I did the wireframe is so that I can offset this. So we'll do other and then offset. Okay, we'll add our offset value here. We'll make it a little bit bigger. We'll say okay, and then cancel. Now, anytime if you want to update the feature, want to change the boundary or whatever, we're going to go to our boundary. We're going to remove. We'll right-click again and do reselect. We'll shift left-click for our boundary here, and then spacebar. So what we did is we moved our boundary out, and then we need to recompute the toolpath to update for any of the changes. Okay. So by offsetting it out, we actually did get some more toolpath here, but you can see it's going towards the edge, this vertical wall here. It's not giving us any more toolpath along the flat area, and that is one of the characteristics of the ZLevel Finish toolpath. Okay, so with the ZLevel Finish toolpath, as the surface starts to flatten out, you're going to get less and less passes. If it's flat altogether, you're going to get 0 passes. Okay, so offsetting the boundary out would not get us where we need to be in this example. Some of the things that reasons why you would go from a mill standard to a mill pro user for ZLevel Finish type machining would be what? What would they be? Well, one of them would be controlling, like right now, this one's always going to start at the top and it's going to work its way to the bottom. Okay, so controlling whether it starts at the top or the bottom. The other thing is going to be whether it does single direction cutting or bidirectional cutting and some other options. So let's go ahead and take a look at that. I'm going to remove that boundary and reselect our other boundary here. And then we'll just recompute to get that toolpath back down inside of there instead of trying to cut around the outside. Okay, so let's look at over here. We're going to take this same feature here. I'm just going to copy and paste it into the tree. I'm going to select the entire model here. I'm going to select this edge as my boundary, and then I'll edit the feature. So in here, I'm going to move over the Advanced ZLevel Finish, and then we'll just remove the ZLevel Finish here. We have the same 1/2-inch end mill. Okay, so when we look at the Advanced ZLevel Finish, you're going to have some more options here when it's under Patterns. Okay, under Patterns, we have start from top or start from bottom. So if you wanted to start from the bottom and work its way up, We can choose start from bottom. If we want it to start from the top and work its way down, we can say start from top, okay? When we look at our method, we have a zig, which would be single direction, zigzag, which would be bidirectional, and then spiral, which will stay in the cut the whole time, okay? See, so these are some reasons why Mill Standard users go to Mill Pro, is to add some additional functionality here, okay? So let's go back for just a second. If we look at our Mill Standard and we're under patterns, you have no options for patterns, okay? When we look at parameters, we have our depth of cut. So here's the thing. If you're a Mill Standard user, it's really easy. There's less options. You can get up and running really quickly, okay? As you go to Mill Pro, you're going to add more features, and generally it's warranted. Depending on the kind of work that you're doing, it's warranted, okay? So let's get back in here. We got our geometry selected. We got our boundary selected. Let's look at some of our settings. So I'm going to do single direction, method zig. Let's go to our leads here. I'm going to do, let's just say a right angle. That's fine for now. And then we will compute. Now, usually one of the things you'll notice is when we did this with Mill Standard, we got the tool path to go all the way down to the bottom. I may have missed it. Are you in version 30? Yes, Kenneth, I'm in version 30. That's correct. All right, so here we go. When we did this one here, if we let me get rid of our top and bottom of settings. So we have our geometry, we have our boundary. When we compute this one, generally we're going to see this one go all the way down to the bottom. Okay. So by the default settings, you can see how this one went all the way down to the bottom. And if we edit our feature here under options, let's see. Cutting extents, it has all. That's the default. So it does have some filters for innermost only or outermost only geometry, okay? But by cutting extents all, it's going to go all the way to the bottom of your part by default, okay? When we look at our Mill Pro, we selected our geometry, we selected our boundary, but then when we look at our toolpath, we only get one pass here, okay? So why are we getting only one pass here versus it going all the way down to the bottom? Well, if we edit our feature and we look at our options section, our cutting extents is set to extents. So it looks at the surface and it cuts to the extents of the surface, or what it feels the extent of the surface is. This is great when you have like a radius profile on a shoulder. It's going to target that very good. But when you have a wall that goes down to a bottom, that's where you're gonna miss out with the default setting. Okay, so with this, we only got one pass at the cutting extent. If we set this to part bottom and we recompute, now we're going to see multiple passes here. Okay, so now we're seeing multiple passes to get down to the bottom. Now our toolpath looks very similar to the Mill Standard. We can see multiple passes to get down to the bottom. We can see some linking moves here. We have our lead in at the beginning. We have our lead out at the end. Looks very similar. Okay, when we get in here and we start making some adjustments, right now you can see that it's going to start at the top and then it's going to work its way down. If we wanted it to start at the bottom, again, we would go under patterns here and we would change this to start from bottom. Now, in order to update those changes, we'll recompute. Okay, so we recompute the toolpath, and now what you're going to see is the tool will start at the bottom, and then it's going to work its way up. Now, the way that this is running right now, that doesn't really make sense to go all the way down to the bottom. So what do we need to do? We need to trim away our unwanted toolpath. We don't want this toolpath going all the way down to the bottom. We just want to address the radius. So what are we going to do? Well, we're going to come in here and edit this feature. We're going to go to our parameters, and we're going to use our bottom of job setting. We're going to make this a -700, just like we did with the Mill Standard. We'll go ahead and compute that, and then we'll see that the toolpath no longer goes all the way down to the bottom. It just goes down to the depth that we want, okay? And so an advantage of the Mill Pro Advanced ZLevel Finish is to start from top down or to go from bottom up. Now, if we come in here and we edit this again and we look at our patterns, right now it's set to a zig only, or a single direction. And if you're a Mill Standard user, you only get single direction cutting, okay? If we go to zigzag and we recompute here, then now we're going to have bidirectional cutting, and it's going to cut in two directions. Generally, the bidirectional cutting I'm going to use more for open shapes versus closed shapes. Actually, it doesn't even look like, did I get it? Let me see here. Zigzag. Yeah, it didn't look like it was doing a zigzag pass. This is coming from the bottom up. Yeah, bottom up, I'm not getting a zigzag there. Let me see here. Let's do top down. Okay. Back plot. Yeah, for some reason that is not working right at this point. So, great scenario, great learning scenario here. What happens if you have a feature in the software that you're expecting to do something and it doesn't do it? What should you do? The answer is email the part to support. Tell them what you're doing and email the part to support. That way you can give them all the information that is necessary, and if there's a problem with the software, we can get it fixed. So that's a pro tip there. If you run into an issue, you do need to report it with support. It looks like I'm having that issue now. Ron says it's on climb only. That could be the case. Let's come back in here. It's just on climb mill. When you go to zigzag, it will do climb and conventional, but it may need to be an open shape in order for that to happen. So I'll give you guys some notes on that, but it will cut in a zigzag. In this particular case, I don't need it to cut in a zigzag. Really what I'm looking for is this spiral, and that's another reason why you go to a Mill Pro, is to keep the tool in the cut, to eliminate some of the retracts that happen, which lengthens your cycle time. So by keeping the tool in the cut, we're going to recompute this here. You'll see that the linking moves are taken away. And then by taking away those linking moves, we're going to get a better finish on this particular surface. Now, Ron had a question, why is it not cutting the full radius? This has to do with the characteristics of this toolpath. This toolpath is best for more vertical geometry versus shallow geometry. And as the radius comes over this edge here, this definitely shallows out. Okay, so what are some of the ways that you can handle that? Well, if we come in here under our patterns, if we come in here under our parameters, you have machine flatlands. Machine flatlands is an option to machine the intersection of the wall and floor surfaces, or to have a cut at the intersection of the wall and floor surfaces. We have machine vertical walls only. Okay, that would just do the vertical walls only. That's not what we would need here. What we can do is we can add adaptive depths of cut. And the advantage of doing the adaptive depth of cut is it will tighten it up, the toolpath in the shallow area, but not tighten up all the toolpath, which helps to have it be more optimized. Instead of making the cut so small for the worst case scenario, we can use a minimum depth step and a maximum step over in order to tighten up the toolpath in the more shallow area. So by just turning this on here, you're going to see that we'll get some additional passes in this area, or at least that's what I expect. And that is what we got there. So using a smaller DOC is correct, is a way for us to tack that. If you're a mill standard user, you would use a smaller DOC for the entire surface area of the part. If you're a Mill Pro user, you can use our adaptive depth of cuts here, the adaptive depth of cuts. That way it tightens it up just in the shallow area and not across the whole part. So it minimizes additional wasted cutting motions and gives you a more efficient program that way. All right, so we have the adaptive cut in order to get a better finish here. So we're getting more toolpath passes at the top, but not having to have more toolpath passes at the bottom. Okay, we have our spiral cut here, so that way it's staying in the cut the entire time, so we don't get this linking move. Okay, and we can choose to cut from the bottom up or the top down. Zigzag was not ideal for this scenario, but if we had an open shape, we would be able to get a zigzag pass in there. All right, so if there's any questions about the Mill Professional Advanced Z-Level Finish, go ahead and fire that away. Please keep in mind there are a number of other features that are in here. We talked about operation stock at the beginning of the webinar, so we can provide the stock condition, the in-process stock, and you can use that as a 3D boundary. There's rest finishing stock, and then there's also check surfaces, where if we wanted additional material to be left on different surfaces, or if we wanted to trim away toolpath, we can do so with our check surfaces, okay? So if there's any questions about that, go ahead and fire away. Otherwise, we're going to move on to our next toolpath. Now, this is a Mill Premium toolpath. If you are a Mill Pro user, today's promo code level up at the 877-333-4903 number will get you our additional surface-based toolpaths. Now, these toolpaths work a little bit differently. I've had a number of users, whether it's machining compound radiuses. I had a lollipop cutter for an inside edge break doing undercut this week, which was a Mill Premium application. So the Mill Premium gives you the additional surface-based toolpaths that we get a lot of control from. Okay. Today's example of the Mill Premium toolpath is going to be the cuts along curve. We could use cuts along curve. We could use a morph strategy. There's a number in here, but this is the one that I wanted to use. It does remind me of a ruled surface, the result that we get here. So let's take a look. We're going to do cuts along a curve. We're going to pick up our 1/2-inch ball here, and we're going to go to our parameters. Now, when you're a Mill Premium user, you can see that the interface of the wizard is a little bit different. We get into these tabs here. All the other toolpath wizards use the next finish interface. The Mill Premium toolpaths use these tabs here, okay? And each of these tabs have different options and features. Some are relevant, some are application specific, some are toolpath specific. So there is a lot going on here. When you're dealing with cut along a curve, there's two pieces of geometry that we need to select. One, we need to select our edge curve, and two, we need to select our drive surface, or really drive surfaces. Okay, Vic has a question, or maybe a standard user could program the radius twice, top down using depth limits with different stepovers. There are creative ways that you can use the software, Vic, so I would agree with you. What you generally are looking for is a consistent workflow. So I can do step 1, step 2, step 3, and I can get what I need to get. That way, once you have a consistent workflow, you generally are going to get consistent results at the machine, and that's going to make your whole process a lot easier. If you have to do quote-unquote trickery, you can definitely get it done, but as your production level goes up, it will slow you down with trickery. Okay, so I do recommend looking at the software and the features and what best benefits you, and really understanding how those features work. And for ZLevel Finish, the advanced ZLevel Finish with the adaptive step-down is a really good feature. So if you don't have it, I would recommend considering it. Okay. All right, so back to cuts along a curve. We have two pieces of geometry here. We have our lead edit curves, lead curve that we have to select, and then we have our drive surface or surfaces that we need to select. Okay, we have tool axis control. Now I'm a 5-axis user here, so I have 5-axis output. If you're a Mill Premium, it will be limited to 3-axis. You don't have to worry about tool axis control. Gouge checking, this is like the gouge checking we have with the Mill Professional. So very simple. Let's see here. Troy Troy made a comment. Are adaptive features always the best choice? I don't know if anything is always the best choice, but adaptive toolpaths and stepovers generally will give you better attacking of your material. So they're good to use. What I recommend you do is you test them in your shop and report back and let us know what you find. I find that a lot of scenarios adaptive is the way to go, but there are a lot of classic, old school conventions and methods that are still very true to today. A lot of it has to do with your equipment and what you guys are doing there. Hey, no problem, John. We'll see you in the next one. Okay, so we got our gouge checks here. Gouge checking is basically the same as the Mill Pro. You can select surfaces and determine what happens. You will add some additional linking options. This is a very useful feature of the software, but the area that I really need you to focus on here is this area right here, which is the retracts. Okay, so when you're trying to control the retract, where the tool starts and ends, this generally is where people get lost. So this is where you set that with the Mill Premium toolpath. So we're actually going to come in here and we're going to set our retracts. This is fine because I have the 0 at the top of the part, but we can come in here and make some additional changes if that was necessary. So we got our retract set up. And that's all I'm going to cover on these menus right now. Let's go back to surface path. We're going to do our edit curves here. We're going to do lead. I'm going to, let's see, we'll right click on this edge and choose constant Z. So that's our lead curve. Okay, so this is the edge of the surface there, all the way around, kind of like our boundary. And then we have our drive surfaces. So we'll do drive surface, and then we'll select the surfaces that we want to have the toolpath driven along. So we'll select these surfaces here, and then we'll hit our space bar. From there, I'm just going to compute the defaults, and we'll see what happens. Reginald asked equal distance, equal distance. I definitely agree with you. That is a very useful feature. Edward says, is mill premium better for horizontal machining or rotation around y-axis? It's kind of not really the same. I don't know how to answer that question directly. If you're running a horizontal machine and you're doing 3D machining, then mill premium will be better than mill professional because you have more options for surfacing. Whether it's rotating around Y or X or a C axis, that's not going to play a bearing on whether you would be a mill premium or a mill pro user. A mill premium user is going to give you more toolpaths for 3D machining, kind of like this one here. Now, at first glance, this toolpath is looking kind of strange. We see a lot of retracts happening. Okay, the easiest way to knock those down is just to make this bidirectional cutting. Right now it's set to one way. We're going to set it to two way, and we'll recompute, and that will knock down all those retracts. Now, the other thing that we can do is if we wanted to do a single direction cutting, we could come in and we could make additional adjustments to our links so we can control how it loops back, okay? If we make it, and what I mean by that is if we make this one-way cutting again and we recompute, what's basically happening is it's making a cut, either it's going top down or it's going bottom up, and then it's repositioning for the next cut. And right now it's going to that inch clearance. If we come back in here and we do our links, and instead of retract to clearance, let's make this clearance blended spline, and we recompute. What we're going to see is more of a rounded approach for this. I don't know that this one was necessarily the best option. I probably would want to change that a little bit, but I'm showing you that it's the linking moves that is happening where those clearances are coming from. Now, when you go to the mill premium, you get a lot of options. Just because you have a lot of options doesn't mean you need to use them all, and it's really about finding when to use them, when it makes most sense for the project that you're working on. The point is you do have more options than you did before. Things like changing the start position. So let's go back to zigzag cutting here, and we're going to recompute. Okay, so we have our zigzag cutting here. We're going to come over and we're going to choose backplot, and you're going to see this is where the tool starts on our file. Now, that may be a good scenario in most cases, but it may not be the best scenario in all cases. If you're a mill pro user, you cannot change where the tool starts from. If you're a mill standard user, you cannot change where the tool starts from. If you're a mill premium user, now you can change where that lead-in position would be. And we should be able to go over to our parameters and we can turn on start point. We can click on start point. You have a position. You have some different options here. You have some shifts for linking depending on which toolpath you're using. We're going to go by a position here. We're going to go pick, and I don't know. Let's just click this position here. We'll say OK. We'll recompute, and what we'll see is that the start of the tool, or what we should see is the start of the tool starts where I wanted it to. Of course, in this example, it doesn't show that, but I'm not sure exactly why. I'll have to review that. But you can, with most of the mill premium toolpaths, you can come in here and use this start point control in order to change where it starts cutting from. The other thing you can do, too, is you can change the patterns in which it cuts from as well. Now, there are some carryovers with these options. Some of them are available for some toolpaths and some of them aren't. For me, I don't generally get stuck on things. If I can't get something to do what I want, I will generally change it. and not get stuck on it, because if you spend too much time getting stuck on a feature, then you really do lose production. This one here, if I needed it to move, let me see if there are some other options. We have our lead curve, and then we have a modify start. So in this case, instead of it being from the start point within the toolpath, my assumption is it's going to change based off of this start position here. So I'm going to move the arrow over there. We'll hit our space bar. Let's recompute it, and let's see if that makes me right. Yeah, okay. So with cuts along a curve, generally with like the morphing strategies, I'm going to use my start point control here. In this particular example, the way the toolpath is set up, I can go to my geometry and then my lead curve, and I can right click and modify. And when I modify that, I can move this arrow to different positions, and I believe also by changing the direction, it may change the cut direction as well, whether it works its way this way or whether it works its way that way. Okay, so again, these are 3 ways in which you can program a radius edge. Why wouldn't you just use a corner rounder? Well, it might be a mold-based application where it's an irregular radius size. You may not have a cutting tool. It may be a one-off part, so it doesn't really make sense in order to buy the tooling. You want to use the tooling that you have. So those are some considerations that you have. Those were the 3 toolpaths that I wanted to show you guys here today. So I appreciate everybody sticking around with me and going through this. What I want to do is I want to open it up to open Q&A for the last 10 minutes or so I can answer any questions that you guys may have or cover any other topics that you may want to see. Ron has a question. Can you make it run the cut horizontal? I can make it run the cut horizontal, but not with this toolpath here. This toolpath will generate a perpendicular toolpath to the curve that you select. If I wanted it to run horizontal, what I could do is use one of the other strategies. Okay, so what I'm going to do with this guy is I'm just going to copy and paste him. Okay, I'm going to come in here and look at my toolpath settings. So maybe I'll do a morph routine. So we'll do morph between 2 curves. We'll use the same tool. We'll look at our parameters. So we have our first curves here. So let me see. I'm going to right click on this edge and choose constant Z, and then spacebar. We have our second curves here. I'm going to right click on this edge and do constant Z, and then spacebar. We have our drive surface here. What I'm going to do is blank that real quick. So I'll select the drive surface that I want the toolpath driven along. We'll do zigzag. This is fine. We'll compute this, and this will run horizontal. Now I still have the linking that I would need to address here. I could choose to run it as a spiral, or I could adjust some of the linking moves here. So that is a way in which you could run it horizontal, but with a different toolpath. Okay. All right, very good. So those are the topics that I wanted to cover. If there's any other topics you guys want to bring up, let me know. If you're new, see you next week, Edward. If you're new to our webinar here, if you could just say this is my first webinar, I'd appreciate that, so I know all the new guys that we have in here. Again, like we talked about, we do offer promotional, like we incentivize you guys. If you show up and you get some of the free training that we're offering here, we want to incentivize you and give you these tools. We do have a promo for all of our attendees today. You would need to call the 877-333-4903. The promo code is level up, and you're going to get a discount when you go from Mill Standard to Mill Pro. Or if you go from Mill Pro to Mill Premium, we're going to offer you a special webinar discount brought to you by the voice of the Bobcat After Dark video series. So trying to take care of you guys here. Hey, Ken, welcome to the first webinar. Any feedback that you have, things that you'd like to see different, or topics that you'd like to cover, please go ahead and let me know. Grant said, I'm sorry for all the questions. Hey, no problem, Grant. I'm glad to see you here today. Make sure to come back for the next one. Tom, very good. You're a V6 user. Hey, if you guys haven't joined the Facebook groups, we have lots of Facebook groups out there. I would definitely recommend you get involved with that. Hey, Ron, thank you so much for showing up here today. Brian says, Yeah, yes, we'll have to see about that. You definitely should come. We've had a lot of in-house people coming to Florida in the colder weather, so I definitely recommend considering some in-house training with us. I would spend some time with you. Let's see, Mark, thank you. Absolutely, Mark, thank you for showing up here today. I look forward to seeing you in the next one. John had a question. I have a post processor for my machine installed, but it will not read the file. What am I missing? You have the post processor for your machine, and it's not reading the file. Which file is it not reading? Is it not reading the G code? Is it not reading the post processor? I need some more information there. Hello, Mike. Let's see here. Thank you so much, Michael, for showing up. I appreciate the feedback. Look forward to seeing you in the next one. Scott said, can you show an example of undercutting with a keyway or key seat cutter? You mean a T cutter or dovetail? What do you want there, Scott? Let me know. Let's see here, Grant. Can you build onto an existing toolpath? I'm not sure what you mean. I'm curious of what CAM software you've used in the past. One of the things that you may be talking about here is all of your toolpaths. If you right click, you can go to the toolpath editor. This editor has a bunch of different functions in here to break, move, and edit your toolpaths. So yeah, okay, I understand what's going on now. The workflow here is going to be a lot different for you than it would be in some of the classic versions of the software. You're no longer drawing toolpath with BobCAD. It creates toolpath for you. If you do want to edit the toolpath directly after it's generated, you can use the toolpath editor for that. If you right click on the feature and you go to edit toolpath, this is how you can edit that toolpath. I would recommend you watch the videos. I did 2 videos on the toolpath editor that I think would really help you. Very good. John has a question. I put on a 3.5. Okay. Yeah. Southwest. Okay, so John, what you're talking about there is probably the file extension and then the name of the file. Those two things, the dot naming it the .cam and the naming convention for the file is probably getting you stuck. If you just email support and ask them, they'll let you know. Or if you call Jason at Jason Lawson at SWI, he's one of their support guys. He can get you sorted out, no problem. Mike says, I have been using lathe today and the simulation has X and Z axis reversed. How do I reset this to match the drawing? Mike, in the display of the software is less important than the posted code. I would post your code and make sure your X and Z is set up correct. Hey, no problem, John. If you have more questions or you want to work direct, you can always email me at al@bobcad.com with any questions, and we can talk after the webinar. Let's see here. Do we need multi-axis Pro post-processor using multi-axis toolpath even in 3-axis machine? No. No, you do not. Rogue? Is it Rogue? Okay. No, you do not. You can use your standard post-processor, one of the Haas post-processors, any of the posts that are included with the software, or that you may be running. When you're in 3-axis, it doesn't matter whether you're Mill Pro, Mill Premium, Mill Standard, Mill Express, the post processor will work the same. Let's see here. Russell, okay, we'll see you next time. Jim, we'll see you next time again. I appreciate each and every one of you spending some time with me here today. I really do these webinars to spend time with you, to learn from you, to share ideas, and I really enjoy doing it. So I want to thank each and every one of you for making it possible to create fewer steps, better cuts, and more profit with your BobCAD software. Again, our promo number for today, promo code Level Up, Mill Standard to Mill Pro to Mill Premium, 877-333-4903. Pass it along. Friends, family, even enemies, it's all good. We're here to help you with your CNC programming needs. I appreciate you all spending some time with me here. Unless you have any additional questions for me, we're going to go ahead and see you in the next one. So thank you so much.